In this lecture, I am going to explain different types of chips and tool wear. So, the main aim of this session to familiarize students with the different types of chips and main instructional objectives. This session is designed to identify different types of chips, understand how the tool wear is taking place, and after end of this session, so you should be able to demonstrate different types of chips and explain tool wear. Now coming to the types of chips. When a cutting tool comes into contact with a workpiece during the machining, chips are formed as a result of material removal. The type and characteristics of chips can provide valuable information about the machining process. Here are some common types of chips generated during machining. One is continuous chips, second one is discontinuous chips, and the third one is built up edge chips, that also you can call it as a BUE, built up edges, and the final is serrated chips. Mainly these are the four common types of chips are formed for while machining any type of material. Now let us see that one by one how in which cases these different types of chips are forming will explain now. Now first we will see that continuous chips. The continuous chips are long continuous and typically occurs when machining ductile materials such as aluminum or copper. So they are formed when the shear plane remains continuous and unbroken during the chip formation process. Now let us see that here how the tool is moving against the workpiece and the chip is forming. Now you can see that this is the chip form. This chip is continuous. This is the long. There is no broken. It's a continuous chip formation is taking place. Okay. So now the tool is fitting against the workpiece and the chip, that material is removed in the form of continuous ribbon. The chip is forming. So it's happening mainly characterized by the long continuous strands of material that are removed from the workpiece as the cutting tool engages with it. The continuous chips are commonly observed when machining materials such as aluminum, copper, mild steel and various alloys. So the formation of continuous chips is primarily influenced by factors such as the cutting speed, feed rate, depth of cut and the mechanical properties of the workpiece material. So the continuous chips are mainly depends upon these machining conditions, main that cutting speed, feed rate and depth of cut. It influences the formation of the continuous chips. So understanding the mechanics behind continuous chip formation is crucial for optimizing machining processes and achieving desired outcomes. So when cutting tool comes into contact with a workpiece, it creates a shear plane where the material is deformed and ultimately removed. In the case of continuous chips, the shear plane remains relatively stable and continuous throughout the chip formation process. This stability is attributed to the ductility of the workpiece material, which allows it to undergo plastic deformation without fracturing. So the continuous chip formation process can be broken down into several stages. Initially, as the cutting tool penetrates the workpiece, it generates a primary shear zone. This zone experiences intense shear stresses and high temperatures due to the friction between the tool and the workpiece. The material within this shear zone undergoes plastic deformation, resulting in the formation of chip. Next, coming to the second category, that is a discontinuous chips. Discontinuous chips, also known as segmented chips, are a type of chip formation that occurs during the machining process when cutting the brittle materials. So unlike continuous chips that are formed in ductile materials, discontinuous chips are characterized by short, broken segments or pieces of material that are separated from the workpiece as the cutting tool engages with it. Now, we can see that how the discontinuous chips are forming as illustrated in the figure. Now, you can see that. So, these are the chips are the discontinued. Now, you can see earlier in continuous chips it is coming like a ribbon. Now, once the chip is coming up to certain length, it is separated. Okay. So, this discontinuation is taking place, mainly it is happening for while machining the brittle materials. This chip formation phenomena is commonly observed when machining materials such as cast iron, ceramics and certain composite materials. This discontinuous nature is happening. The formation of discontinuous chips is influenced by various factors including cutting conditions, tool geometry, workpiece material properties and the interplay between compressive and tensile stresses. In the case of discontinuous chips, the shear plane experience intermittent features or breaks resulting in the formation of segmented chips. The formation of discontinuous chips can be attributed to the interplay between compressive and tensile stresses within the material. The process of discontinuous chip formation can be divided into several stages. Initially, as the cutting tool penetrates the workpiece, a primary shear zone is created. This zone experiences compressive stresses and intense deformation. As the tool advances, the material within the shear zone undergoes localized fractures resulting in the formation of segments. These segments are then separated from the workpiece and the process repeats as the tool continues its path. Workpiece material properties such as hardness and brittleness significantly impact the formation of discontinuous chips. Brittle materials with low ductility are more prone to segmented chip formation. In contrast, materials with higher toughness and ductility tend to form continuous chips. Next, coming to the third category of chips, that is a built up edge BEU chips. So, the built up edge chips are a type of chip formation that occurs during the machining process when cutting certain materials, particularly those that are soft or sticky type of materials. Now, you can see that how the built up edge is formed is illustrated in this diagram. Okay, and once the material is flowing, that cutting, see that the direction of velocity, okay. Now, this is the chip and this is the tool. Okay, so now the chip is forming. Now, you can observe here, so there is the edges are forming. Okay, here also there is edges are forming like this. So, these are called as a built up edge. These are called as a, so while machining, the chips are forming on the surfaces. It's because of the sticky nature of the material and it stick to the on the surface of the tool, then one after the other it will be overlapping and it will be forming as a edge. That edges are called as a built up edge. So, this built up edge chips are characterized by the accumulation of material on the cutting tools, cutting edge during the chip formation process. This phenomena can have both positive and negative effects on the machining operation. So, the formation of built up edge chips is influenced by various factors including the material being machined, cutting conditions, tool geometry and the presence of lubrication or coolant. So, when a cutting tool engages with a workpiece, it creates a shear zone where material is deformed and ultimately removed as a chip. So, in the case of built up edge chip formation, the material tends to adhere and accumulate on the cutting tool's cutting edge instead of being completely removed. Because of this accumulation, the edges are forming one after the other, and it build up, it's forming at the edge on the surface of the tool. So, this adhesion is often caused by factors such as high temperatures, friction, and the properties of the workpiece material. So, the formation of built up edge chips can have both positive and negative consequences. On the positive side, the built up edge can act as a protective layer, reducing tool wear and improving the tool life. Because once that edge is formed, once the chip will come, the chip cannot move behind this edge. Once that edge, the tool will come on that edge, so that it's not contacting the surface of the tool, and the tool life will increase. That is the one advantage of forming of these built up edges. It can also help in achieving better surface finishes by reducing tool chip contact and minimizing surface damage. However, there are also potential drawbacks associated with built up edge chip formation. The accumulation of material on the cutting edge can lead to variations in chip thickness and quality. Next, the last one, serrated chips. Now you can see that the serrated chips, so this is a workpiece, okay, and this tool. Now the how that chips are forming, you can observe here, okay, you can observe here. So the cutting direction, tool will move in this direction. The chips are forming in this, it looks like the sharp tape, okay. So this here one formation is coming, and here is another one, here another one. This is the shape of the form the chips are forming. So this type of the chips, you can call it as a serrated chips, okay. So that depends upon the material. Here we are showing the some of the geometrical variations of the chips. Here the thickness of the chip before cutting the material, okay. So then you can see that the distance ds, the ds is the distance between one chip formation to the another chip formation, okay. So now this will be happening, and this length up to here, you can see that that length ls, okay, and the axial length t naught. These are the some of the geometrical dimensions we are used to analyze the serrated chips. I hope that you understand how the serrated chips are forming compared to the continuous chips and discontinuous chip and built up edge formations. Now you can see that the serrated chips, also known as sawtooth chips, how the sawtooth will be forming in the same shape these chips are forming, okay. So the built up chips are a type of chip formation that can occur during the machining process when cutting certain materials such as stainless steel, titanium, and high temperature LS. And also you can observe this the tool orientation of tool against the workpiece. Now here you can see that this is the surface of the tool. The surface of the tool is perpendicular to the direction of the workpiece. Mainly there is in the earlier cases the tool having the certain inclination, but here you see that the surface of the tool is perpendicular and it will move, okay, in this direction. The once that material is removed, it's moving in a perpendicular in the upward direction. During this process, this type of the sharp tooth type of shape is forming before removing from the tool. Mainly it is happening while machining the special materials like stainless steel, titanium, and high temperature alloy materials. Once machining, this type of chips we can observe. So the serrated chips are characterized by their way or serrated appearance with periodic changes in chip thickness along their length. So the formation of serrated chips is influenced by various factors including cutting conditions, tool geometry, workpiece material properties, and the interplay between strain hardening and thermal softening. So, serrated chip formation is often associated with materials that exhibit strain hardening behavior, where the material becomes stronger and more resistant to deformation as it is worked. So, in the case of the serrated chip formation, the shear plane experiences periodic changes in strain due to the interaction between the cutting forces and the material properties. So, as the cutting tool engages with the workpiece, high localized temperatures and strains are generated at the tool chip interface. So, the combination of strain hardening and thermal softening causes the material to undergo localized shearing in narrow bands or zones. These adiabatic shear bands form the wavy pattern observed in serrated chips. Managing serrated chip formation involves a combination of tool selection, cutting parameters, and cooling strategies. So, choosing appropriate tool geometries such as positive rake angles or specialized chip breakers can help control chip formation and break the serrations. Otherwise, it's a saw type of it will be forming. So, in between you have to break it by providing this specialized formation. And coming to the tool wear. So, because we have seen the different types of chips, how it will be contacting and leaving on the surface of the wear. Because of this, wear and tear of the tool is also happening. So, the tool wear is a common phenomena that occurs during machining operations, where a cutting tool gradually loses its original shape, sharpness, and effectiveness over time. So, it is a result of the mechanical and thermal stresses that tool experiences during cutting, which leads to the gradual material removal from the tool surface. So, there are several factors that continues to tool wear. One of the primary causes is the interaction between the cutting tool and workpiece material. So, the workpiece materials properties such as hardness, abrasiveness, toughness, and chemical composition play a significant role in determining the rate and extent of tool wear. So, harder materials tend to be more abrasive and cause faster tool wear, while softer materials may lead to more adhesive wear. So, another factor is cutting conditions, including the cutting speed, feed rate, and depth of cut. Higher cutting speeds and feed rates can increase the temperature at the tool chip interface, leading to thermal wear or tool deterioration due to high heat. Different types of tool wear can occur during the machining process. These include the flank wear, crater wear, and nose wear, built up edge formation. So, according to that formations, we can categorize the wear of the tool is in these four categories. Thermal cracking also sometimes you can consider because of the high temperature formation while machining the workpiece, that will lead to the crack the tool surface. So, in this session I explained what are the different types of chips and the tool wear.